My name's Todd Craig. I'm with Rocky Mountain Mechanical. I'm the site superintendent, and this is the mechanical systems training for domestic water systems. The objective of this, the purpose of this training is to instruct qualified UVU personnel on the domestic water systems for the new science building. Attendees to this instruction will be informed on the location of the main water entry, the general routing of the piping system, service shut-off valve locations, the heated hot water generation and plumbing fixture service. The system design, as designed by the engineer of record, the domestic water system for the structure enters on building level 0 and is routed through the rest of the structure, primarily through corridor ceiling cavities. Main risers through the building, including service to mechanical systems located in the penthouse, may be found in piping enclosure shafts in the locations indicated. Piping systems are provided with piping indicators, flow arrows, and valve tags indicating service. Over here we have what's called the 3-step PRV station. The entering water comes in through this valve here. That's your main water shutoff valve. Goes up through the system, hits the tree. You're going to hit this first regulator first. This one will be set at 70 psi. Once this one can't meet demand, the second one will kick in at 68 psi. And then when it doesn't make the demand, the third one and the big one will take up the rest of the demand. It'll be set at 66 psi. So once we get through the PRV station, it's going to head up the domestic cold water loop, which goes up this pipe and routes through the building to do the domestic cold water side. That's basically your bathrooms, your drinking fountains, stuff of that nature. Once it hits this T right here and goes through this reduced pressure backflow preventer, it becomes industrial cold water. It goes up this pipe and feeds up through the building. The industrial cold water feeds all of the labs. So once it hits there, there's no cross connection point. That's it for here.
What's that PRV set at?
This is just a reduced pressure backflow preventer is all that is. So this will, whatever's coming out of here.
What's that down there on the bypass valve line on the bottom?
The one on the bottom is a hose bib outside of the building. So you've got a shut-off valve for it.
That's nice.
Okay. And then I give you a hose bib connection here on the domestic side, and right behind you, another hose bib connection on the industrial side. Any questions?
No, that sounds good.
Yeah. Yeah. We were just talking about this. The demand on this one's 2 degrees or 2 points difference, right?
2 pounds difference, yep.
Well, if it calls for this one here, but this is a lower rate.
Okay, what happens, this one will be set at 70 pounds, so this will take up most of the demand, a few toilets flush here and there. Start opening up more and more, the demand's going to become greater, you're going to need more water, this one will kick in to make up the balance.
Okay, well, I understand that, but how's that gonna kick in if it's a lower rate than, well, that?
This one will be set at 70. Once that demand, you open up more of them, your pressure's going to drop more substantially.
That's
This
why.
one will see it,
Okay,
then that one will open.
all right.
Why we've set it up this way is, this is the littler one. Obviously for maintenance issues, this is the easier one to fix. This one's going to do most of the work,
Yeah,
okay? So it's just going to be a step process here.
okay.
For maintenance issues, it's cheaper to fix this one than this 4-inch.
Yeah.
Easier too.
So,
Okay,
all right. Okay, now we're outside of one of the lab rooms, and this is typical of every lab room. Right outside the main door to the lab, you'll have a set of shut-off valves It'll shut off all the systems in that lab. That's about it for that. I told you last time, on the grid they're going to label it service valves. So you have that one right there. Okay, we're on level 1 in the corridor from the old Pulp Science building to the PE building. And right above us here, there's a ball valve right there. And another one on this line here. The bigger line is a domestic hot water supply. This is where it ties into the campus. And the littler line is the recirc. That's it for this. Okay, we're on level 1 in the janitor's room. This is where the domestic hot water heat exchanger comes in and the industrial hot water reduced pressure backflow preventer. So as you notice up above you, this is where the domestic hot water from the campus comes into this room, down the pipe, and hits this, which is the reduced pressure backflow preventer on the hot water side. Once it goes through this, it becomes industrial hot water. Goes into the building and routes through the corridors and through the various floors. Okay, right behind me and above me is the hot water heat exchanger. You've got the inlet water coming into it and going back out to the campus on the research side. What this does is keep the industrial hot water loop hot. So it's just basically a heat exchanger, campus side, industrial hot water side. You've got circulating pump for it. They're all controlled up off the switches and controlled through the arms. Up above us, in the corners up there, are 2 little circulating pumps. That is on the domestic hot water research side. That's coming right out of the campus. So it just researches this loop, researches the domestic hot water side, and goes back to the campus. That's it for here. Okay, now we're on level 1 in the north corridor. We're looking at a typical drinking fountain setup. So where you have a drinking fountain hung on the wall, right above it, you'll have a shut-off valve. And this is typical of all drinking fountains in the building.